What would life on Mars be like if we could live there one day? Would it resemble life on Earth in the desert? What equipment would we need to make sure we didn't run out of resources? Intriguing questions, but also fascinating ones that we've all asked ourselves. Indeed, the hypothesis that we might one day live on Mars is becoming increasingly plausible. NASA has even launched a competition, the 3D Printed Habitat Challenge, to find habitat designs that can be created directly on the red planet, so we don't have to transport them from Earth. An exciting prospect, but also a dizzying one. We got a glimpse of what life would be like on Mars on November 8th, once again thanks to NASA. NASA's Curiosity rover, on mission on Mars for over 10 years, filmed its shadow on the red planet's soil for 12 hours. The result is nothing less than the passage of time on Mars, from 5:30 a.m. to 5:30 p.m. The video shows the sun moving across the slopes of Mount Sharp. In fact, it's a bit like being on Earth, but in the middle of a rocky desert. Although you can imagine that life on Mars won't resemble life on Earth, it's hard not to compare these two neighboring planets. In fact, we've been studying Mars for a long time to find out whether, like Earth, it is inhabited, or at least habitable. The first traces of observation of Mars date back as far as ancient Egypt, in the 3rd millennium BC. Incredible, isn't it? It was much later, however, that we began to look for traces of life on Mars. The first serious research on this subject dates back to the 19th century. We had to wait until the 20th century for the first overflight of this planet. 1964. The Americans sent the Mariner 4 probe on a flyby mission over the surface of the red planet. Its main objective? To take photos of Mars in search of traces of life, and to find out what our planetary neighbor really looks like. This was the first flyby mission to explore Mars. Mariner 4 carried out the first flyby on July 14, 1965. And then, surprise, while Mars was thought to be very similar to Earth, the photos actually showed an arid planet with no sign of oceans, rivers, or life. And that's not all. During its mission, Mariner 4 measured Mars' atmospheric pressure and estimated it at 6 HPa compared with 1,013 HPa on Earth. At this pressure, it's impossible for liquid water to exist on the surface of Mars. What's more, the red planet has no magnetosphere to protect it from cosmic rays. Mariner 4 disappointed many hopes, and yet the search for life on Mars continues to this day. Why is this? Because its images also showed the presence of numerous craters on the planet's surface. In other words, Mars not only has volcanic activity, but also meteorological activity just like Earth. What's more, just because the red planet can't support human life, or multicellular life to be more precise, doesn't mean there's no life at all. Since Mariner 4, we've concentrated on finding simple living organisms such as bacteria. Bacteria, on the other hand, are likely to live in a hostile environment, like that of the red planet. After the Viking probe mission, sent to Mars in the mid-70s to find traces of microorganisms, the search for single-cell life on Mars was put slightly on the back burner in favor of another equally exciting question: the search for liquid water on Mars, or rather, the search for liquid water in the red planet's past. Mariner 4's observations were quite clear. There is no liquid water on Mars. Conditions do not permit it. But there may have been water on this planet in the past. As far back as our observations of Mars go, it would seem that the planet has not yet revealed all its secrets. Dear traveler, welcome. Today we're going to retrace the latest discoveries made on Mars. We're going to look back over the last 2 years and take stock of the latest advances in Mars missions. But before you set off on your next adventure, be sure to like the video and subscribe to the channel so you don't miss a thing. Are you ready to embark on this fabulous adventure to discover the secrets of the Red Planet? Fasten your seatbelt and take off now. We've left the troposphere and are now climbing into the stratosphere. It's going to be a long trip. Mars is 60 million kilometers, or 37 million miles from Earth. While we're waiting to reach the Red Planet, let's take a look back at the history of Martian exploration. For over 25 years, mobile robots called rovers have been used to explore the surface of Mars. Rovers are astromobiles, in other words, vehicles created for the purpose of exploring a celestial body other than Earth. On February 18, 2021, the Perseverance rover landed on our neighboring planet. It is the 5th NASA rover to travel to Mars after Sojourner, Spirit, Opportunity, and Curiosity. Perseverance is the little brother of Curiosity, which landed on the Red Planet on August 6, 2012. The two rovers are very similar. You might think they're small, but they're actually 2.2 meters, or 7.2 feet tall, and weigh almost a ton. You may be wondering what these two NASA rovers were used for. To find out, let's take a step back in time. Let's start with the Curiosity rover, successor to the Spirit and Opportunity rovers. Developed by NASA, Curiosity landed on Mars just over 10 years ago, on August 6, 2012. Its landing site was not chosen at random. It landed in the Gale crater, which was once, according to experts, entirely covered by a lake. A distant past that the astromobile will be exploring. That's what Curiosity's mission is all about. NASA scientists hope to glean information about the geological history of Mars by taking a closer look at Mount Sharp, also known as Aeolus Mons, at the center of the crater. A prime object of study, it reaches 5.5 kilometers, or 3.4 miles above the crater floor, and is made up of sedimentary strata that have been slowly deposited over 2 billion years. The mission was scheduled to last 1 Martian year, or 687 Earth days. More than 10 years later, the rover is still plying the red slopes of Gale Crater. And with its help, researchers hope to answer the question that interests them most. Did all the ingredients for life ever exist on the red planet? Today, Curiosity is a veritable laboratory in its own right. Over the past 10 years, the rover has collected and sent back to Earth more than 310 gigabytes of data. This data has been the subject of over 900 scientific articles. Let's continue our journey back in time with some of Curiosity's most memorable discoveries. The rover has made its contribution to a great mystery hovering around the red planet and intriguing scientists. Is there or is there not methane on Mars? In recent years, some observations have reported the presence of methane on Mars, others not. So, true or false? And why does the presence of methane intrigue scientists? Curiosity has detected methane particles at least 6 times in the atmosphere of Mars. Very small quantities of methane, like a pinch of salt in an Olympic-sized swimming pool. Logically, scientists suspected that Curiosity itself was producing the methane it detected. But no, the analyses were conclusive. The methane did indeed come from Mars, a conclusion that astonished scientists. Firstly, because it contradicts the observations of the European ExoMars Trace Gas Orbiter mission, which detected no methane on Mars. But also because on Earth, 95% of methane is produced by living organisms, notably the microbes that help animals digest. So yes, it's true that a small proportion of terrestrial methane comes from the Earth's geological activity. For example, in oceanic ridges, liquid seawater comes into contact with rocks, called peridotites. This contact triggers a serpentinization reaction, releasing methane. Most of this methane is stored at the bottom of the oceans, but a small amount ends up in our planet's atmosphere. Yes, but whatever the process behind methane production, scientists had no idea that it would be found on Mars. After all, to date, no living organisms or liquid water have been detected on Mars. So where does Martian methane come from? But there's another mystery linked to this methane. It's a stable molecule with a life expectancy of 300 years on Mars. Logically, methane should therefore accumulate in its atmosphere. But this is not what scientists have observed. Observations show otherwise. Methane concentrations on Mars fluctuate and are not uniformly distributed. What's more, once measured, they are no longer found in the atmosphere. Researchers have finally found a possible explanation for this mystery. Curiosity's observations were mainly made at night, because its instrument, the TLS, is so power-hungry that it can only function when the other equipment is switched off. It would seem, then, that methane is only present on Mars at night. How is this possible? At night, methane would ooze out of the ground. During the day, it would be stirred up in the atmosphere and diluted to quantities that can no longer be detected by our instruments. The second mystery linked to Martian methane is why it doesn't accumulate in the planet's atmosphere, even though it has a lifespan of 300 years. Something is destroying the methane, but we don't yet know exactly what. Electrical discharges caused by Martian dust? The impact of abundant surface oxygen? The final mystery to be solved is that of the origin of this Martian methane. Several hypotheses have been put forward. Active volcanism? Comet impact? Methane-producing microorganisms present in the depths of the red planet, where the temperature would allow liquid water to be maintained? The hypothesis of active volcanism on Mars has its adherents, especially since Curiosity made another headline-grabbing discovery in 2015, a rare mineral that bears witness to potential volcanic activity. This mineral, extremely rare on Earth, is tridymite. It forms when silica-rich lava reaches high temperatures and comes into contact with water. At first glance, this seems impossible on Mars, where no trace of liquid water has yet been found. Scientists have looked into this puzzle and come up with a possible explanation. There may be a magma chamber beneath Gale Crater. The magma gradually cooled over time. Silica-rich minerals would have developed in this magma chamber, and during a volcanic eruption, would have been ejected. The wind would have moved them and brought them into contact with the water of the lake in Gale Crater. Thus, tridymite could have formed by crystallization, theoretically anyway. After all, no one suspected that the formation of tridymite, an extremely rare mineral on Earth, could occur on Mars. It would seem, then, that Mars was once the scene of far more violent volcanic activity than we might have thought. The Curiosity rover was responsible for another important discovery in 2016. The discovery on Mars of a chemical element found on Earth in arid zones where a lot of water has evaporated, boron. As part of its mission, NASA's robot surveys the slopes of Mount Sharp, analyzing the sedimentary layers every 25 meters or 82 feet. One of the samples taken revealed the presence of several elements, such as sulfur, nitrogen, oxygen, phosphorus or carbon, but also boron. All these elements are useful for nourishing microbial life. As for boron, it is used to stabilize the sugars used to manufacture RNA, a nucleic acid present in virtually all living beings and in some viruses. It could be that in this crater, which was once home to water. Is it possible that a form of life developed billions of years ago? But even if all the conditions were met, that doesn't mean that there was microbial life on Mars at that very spot. We're still missing the proof. Over the years, Curiosity's observations have considerably advanced our understanding of the red planet. But they have also been invaluable to science in the broadest sense of the word. For example, during its many journeys over the hills of Mars, the rover noticed that rocks prevented ionizing rays from reaching it. Could these rocks replace the magnetosphere that our neighboring planet lacks? This information could prove invaluable when it comes to preparing future astronaut voyages to the Red Planet. Curiosity's mission is scheduled to last until September 2025, and perhaps even until 2030. Between now and the end of its mission, the rover will be studying a region it has not yet traversed, whose soil is mainly composed of sulfates. These analyses should tell us more about the climatic transition that led to the aridity seen on Mars today. Since February 2021, Curiosity is no longer alone in its mission. It is now working with another NASA rover, Perseverance. Let's take a closer look at this astromobile. February 18, 2021. The Perseverance rover has just landed on Mars in the Zhurong crater, accompanied by its colleague, the Ingenuity drone. These two robots are here for one reason: to complete the Mars 2020 mission. A mission estimated at $2.5 billion, and in which scientists have high expectations. What exactly does this mission involve? The idea is to collect samples from the soil of the Red Planet and bring them back to Earth. These samples will be used primarily to better understand our neighbor's geological past and perhaps find traces of microbial life, either in the present or in the past. And why not? Mars once had a denser atmosphere and rich water resources, a bit like Earth. Experts don't believe that Mars was home to intelligent life. Instead, we're looking for traces of primitive microlife. Thanks to Perseverance, NASA now has 2 active rovers on Mars. One of the rover's instruments is the SuperCam. It is, in a way, the rover's eye. The SuperCam consists of spectrometers, a camera, and a microphone. Perseverance is also equipped with a drill, enabling it to excavate the soil of Mars. With all this, the rover is well equipped. The samples collected by Perseverance will be analyzed on their return to Earth. In the meantime, they are sealed in tubes and stored by the rover, which is perfectly autonomous in its mission. If Perseverance collects samples that prove the existence of life on Mars, we'll have to wait until it returns to Earth to find out. In any case, it will be a first. Never before have samples been brought back from space to be analyzed on Earth for possible traces of life. The rover was also sent to Mars to test technologies for potential Martian colonization. For example, it tested a method for producing oxygen from the Martian atmosphere. On April 20th, 2021, 5.4 grams of oxygen were produced from carbon dioxide, enough breathable air for 10 minutes. Perseverance will also analyze local weather conditions to determine what might affect astronauts on a mission to Mars. These missions look promising, especially as the Zhurong crater is an interesting site. This 49-kilometer, 30-mile diameter impact structure is home to a delta that is thought to have formed where water once flowed into a lake. The area must therefore once have been rich in liquid water. Experts have estimated that around 3.5 billion years ago, the Zhurong crater was home to a vast Martian lake, 250 meters or 820 feet deep. Perseverance didn't land on Mars alone. A helicopter drone called Ingenuity accompanied it on its mission. But what is the purpose of this helicopter weighing just 1.8 kilograms or 4 pounds, which carries no instruments apart from cameras? Ingenuity is a true pioneer. It is the first helicopter drone in history to be deployed on a celestial body other than Earth. It was sent to Mars as a test. Flying a helicopter on the red planet remains a challenge. It has to be able to climb into Mars' atmosphere on its own, where atmospheric pressure is much lower than on Earth. But there are other challenges too. The cold, autonomy. But on April 19, 2021, Ingenuity brilliantly rose to the challenge with its first successful hover flight. Since the start of their mission, Perseverance and Ingenuity have exceeded scientists' expectations. A few weeks after its arrival on Mars, the researchers switched on the rover's microphones. We were able to discover the sounds of Mars. In June 2021, the rover left its landing site to begin drilling operations in search of biosignatures. These biosignatures can be, for example, traces of mineral salts or organic matter. The idea is to prove that microbial life did indeed exist on Mars when the planet was still home to liquid water. After an initial failed drilling, a second attempt was made in September and was successful. A mechanism was then put in place. Ingenuity acts as a scout for the rover, which continues to drill. In January 2022, the Perseverance arm was blocked for several days by rocks. But the rover lives up to its name. The little routine set up by the two robotic colleagues continued. While the rovers continue their mission on Mars, NASA and ESA researchers are already planning the next missions, starting with the one that will return the samples to Earth, probably in 2026. In concrete terms, how do the researchers plan to recover the Perseverance samples? The idea is to send two vehicles to Mars, a rover to retrieve the tubes, and a rocket equipped with a container. The rocket would take off from the Martian surface and place the container in orbit around Mars. The Earth Return Orbiter (ERO) spacecraft will retrieve the container and return it to Earth. If all goes well, the samples collected by Perseverance could be back on Earth in 2031. A third rover is currently on Mars, with missions similar to those of Curiosity and Perseverance. The Chinese rover, Zhurong, Arriving on the Red Planet on May 14, 2021, shortly after Perseverance, it will be the first Chinese rover to set foot on Mars. Until now, only NASA has been able to send these rovers to the Red Planet. Like Curiosity and Perseverance, Zhurong aims to find hypothetical traces of mineral salts and organic matter. Put into hibernation in the spring of 2022, the Chinese rover was due to wake up in December 2022, when Martian temperatures had risen again. But recent images show that it is still stationary on the Red Planet's surface, and its solar panels are gradually being covered with dust. Fortunately, Chinese scientists have plenty of data to work with until the rover wakes up. And it looks like the rover had time to make a major discovery before it went into hibernation. Zhurong has discovered traces of liquid water in Martian sand dunes formed only a few 100,000 years ago. These dunes are located where the rover landed on May 15, 2021, in the southern part of Utopia Planitia. The data collected by Zhurong is astonishing. The surface of these dunes is crusted and dotted with cracks and other traces that are usually formed by interactions with fluids. But that's not all. The composition of the dune's surface is rich in elements such as hydrated sulfates, opal, CT, iron oxides, and chlorides. A chemical signature typical of reactions with liquid water. Reactions that would have occurred relatively recently, since the dunes are only 1.4 to 0.4 million years old. These observations are unprecedented. There could have been liquid water on Mars in the very recent past, although nowhere near the quantities found in the ancient lakes of the Gale and Jezero craters. The researchers believe that this liquid water could be the result of the transfer of water vapor from the polar caps to the equator during periods of cooling in Mars' lower latitudes. In other words, this region would have repeatedly presented more favorable temperatures than the rest of Mars, with moisture conducive to life. From the USA to China and Europe, international space agencies are sending increasingly sophisticated equipment to Mars. But clues are also arriving directly from Mars to Earth, such as the Black Beauty meteorite. In 2011, mysterious fragments of an unknown rock that crashed to Earth billions of years ago were discovered in Morocco's Western Sahara Desert. This mysterious black rock has been dubbed Black Beauty. Its real name is more complicated: Northwest Africa 7034, or NWA 7034. Scientists took numerous samples of this rock and concluded that it came from our neighboring planet. Black Beauty was therefore composed of 4.5 billion-year-old Martian rock, a true gift from heaven. After further research, it was finally estimated that this rock was formed during the very beginnings of the solar system, when the Martian and terrestrial crusts were not yet complete. We were also able to identify the crater of origin of this mysterious rock from among nearly 80,000 candidate impact craters. This crater, located in the southern hemisphere of the Red Planet, has been named the Karatha crater. But how did Black Beauty land on Earth? It's between 5 and 10 million years ago. An asteroid collides with Mars, creating the Karatha crater. Fragments of Martian crust are ejected into space. Among them, Black Beauty, ejected at a speed of 5 kilometers per second, or 3 miles per second. The rock travels through space for 5 to 10 million years, ending up on Earth. The study of Black Beauty is crucial. This rock contains the oldest Martian fragments ever found, dating back 4.48 billion years. These fragments show astonishing similarities between the ancient crust of Mars and the continents of today's Earth. According to some researchers, Black Beauty even holds the secret to the first 10 million years of the history of Mars, and by extension, of all telluric planets, including Earth. On Earth, it's impossible to find rocks this old, as plate tectonics pull them back towards the core. This little rock, weighing just 320 grams, is invaluable for understanding the history of Mars, and we didn't even have to go and look for it on Mars. What's next? Scientists would like to send a probe to Mars to explore the area and exploit this lead that has literally fallen from the sky. The idea is to glean valuable information about the formation of rocky planets 4.5 billion years ago. And why not, at last, understand why until now no equivalent of our Earth has ever been found in the immensity of space? We've now reached our destination. Before you lies the planet Mars, the red planet, our neighbor in the solar system, yet one that still conceals so many secrets. Ever since the Perseverance rover and its colleague Ingenuity joined Curiosity on the surface of Mars, new discoveries have been consistently challenging what we know. Almost every month, new scientific publications reveal well-kept secrets about the red planet. Let's take a look at the latest discoveries on Mars. Let's start by going back in time 2 years. It's March 2022. A photo from the Curiosity rover catches the attention of scientists. It's a mineral, concretion, barely 1 centimeter or 0.3 inches wide, flower-shaped, and bearing an uncanny resemblance to our terrestrial sand roses. It has been named blackthorn salt. You'll understand why in a moment. As you can see from this photo, the concretion has several arms, which are connected at the base. This is hardly surprising, as it's not the first time such a formation has been photographed on Mars. In 2008, the Spirit rover photographed a whole series of such concretions in the Gusev crater, nicknamed cauliflowers. This time, however, scientists have turned their attention to the formation process of this Martian sandrose. It is thought to result from a rearrangement of minerals, a process associated with the presence of sulfate-saturated water. In a word, this concretion would be formed like our sand roses on Earth. Indeed, its appearance is reminiscent of an evaporitic concretion. Evaporites are sedimentary rocks like gypsum or rock salt, formed by crystallization in shallow basins subject to strong evaporation. They are found, for example, in lagoons and the Dead Sea. Terrestrial sand roses are nothing other than gypsum crystallizations in a sandy environment, such as the desert. Hence their magnificent orange color. They don't form in exactly the same way as Dead Sea gypsum, for example, but the process is similar. In an unconsolidated medium such as sand, gypsum crystals are soaked up by groundwater rich in calcium sulfate. As the water table evaporates, it becomes more concentrated in ions until saturation allows the minerals to crystallize. Gypsum crystals then grow, pushing aside the sand that surrounds them. This is why on Earth, sand roses are found buried under several meters of sand. The Martian concretion could be the result of the same type of process. Curiosity found it in the same type of soil, a sandy soil, but on the surface and not buried in the sand, certainly due to erosion by Martian winds. This discovery speaks volumes about the presence of water in the red planet's soil. So there's probably water in the form of brine in the subsoil of Mars. And why blackthorn salt? Because this sand rose looks more like a blackthorn flower than a rose. Let's keep moving forward in time in search of the red planet's latest secrets. It's now May 4th, 2022. While Perseverance's mission has only just begun, that of NASA's InSight probe is nearing completion. Landed on Mars on November 26, 2018, it officially ended its mission in December 2022. InSight is equipped with a heat flow probe and a seismometer. Its objective? To analyze the geological development of Mars. The data collected by this NASA probe has enabled us to confirm that Earth and Mars are quite similar in terms of structures. With just a few differences, the red planet has a larger liquid core and a thinner crust than previously predicted. With just a few months to go before the end of its mission, the InSight probe has recorded the largest Martian earthquake ever recorded. In fact, it's the most powerful earthquake ever recorded on an alien planet. Or should we say, Marsquake? Because on the red planet, there are phenomena similar to our earthquakes, even if there are no tectonic plate movements. Since 2018, the InSight probe has been recording all these Martian tremors to study their causes. On May 4th, it hit the jackpot. InSight recorded a Martian tremor of magnitude 4.7 that lasted over 6 hours. Of the more than 1,300 tremors recorded by InSight, this was by far the biggest. What could be the cause of an earthquake of this magnitude if Mars has no plate tectonics? The most likely hypothesis is that a large meteorite hit the red planet. Using all the probes currently orbiting Mars, scientists have looked for traces of a possible collision, but nothing. If there had been such a collision, we'd have found dust flying into space. A new impact crater would have appeared on the surface of Mars, with an estimated diameter of 300 meters or 980 feet. But nothing has been found, so this is not a collision. The only possible explanation is that this magnitude 4.7 earthquake was caused by internal Mars activity. Because the cooling of the Martian crust is not homogeneous, this could generate stresses. These tensions could lead to greater mechanical stress releases than previously thought. Experts are still not 100% sure why these earthquakes occurred. All that is known is that the more we know about the formation of the Martian mantle, the magma currents at work on Mars, or the reason for the loss of Mars' magnetic field in the past, the better we'll be able to solve these mysteries. Let's move forward a little further in time. It's October 27, 2022. NASA announces the discovery of a gigantic meteorite impact crater on Mars, a first since we began observing the red planet. This meteorite impact, measuring 150 meters or 490 feet in diameter and 21 meters or 69 feet deep, has once again been discovered by the InSight probe. It is the largest meteorite crater ever discovered on a planet. Nearby, a second crater was discovered, 130 meters or 425 feet in diameter. NASA has reconstructed a sketch of the meteorite that would have caused such an impact. Its mass would have been between 250 and 650 tons, for a size of 5 to 12 meters or 16 to 40 feet. The impact speed would have been 7.5 kilometers per second or 4.6 miles per second. Impacts caused by this giant meteorite date back to December 24, 2021. At that time, the InSight probe recorded a magnitude 4 earthquake on the surface of the red planet. The tremors caused by the impact are said to have thrown up boulder-sized chunks of ice, which you can see in white in the photo released by NASA. It's fascinating enough to have observed this phenomenon, as such collisions haven't occurred on Earth for centuries. But it's also fascinating to have been able to find an impact of this size. The impact caused blocks of ice to emerge, ice which lies beneath the Martian surface. Ice means liquid water. Liquid water means potential life, but also resources for a future human settlement on Mars. This is not the first time that ice has been discovered on Mars, although it is true that it is unusual to find it in a region so close to the Martian equator. In 2018, the Mars Reconnaissance Orbiter observed ice on Mars in 8 locations. As you can see from the photo released at the time, the ice was distributed in superimposed layers just a few meters below the surface of Mars and up to several tens of meters deep. And this on the side of 8 Martian cliffs in the red planet's northern and southern hemispheres at latitudes between 55 and 58 degrees. A discovery that caused a sensation in the scientific world, even though it was already known that there was icy water on Mars. As early as the 1780s, British astronomer William Herschel was already observing variations in the size of the polar ice caps over the seasons. In 2004, the European Mars Express probe confirmed the presence of ice, as did samples brought back by the Phoenix lander in 2008. But that was at a latitude of 68 degrees, close to the Martian North Pole, and not so close to the equator as in 2018 or 2022. In any case, all these observations of icy water have confirmed that Mars is a frozen planet. It is covered with permanently frozen ground at the equator and superficially beyond 45 degrees latitude. The temperature on the surface of Mars is almost always negative, dropping as low as minus 140 degrees Celsius or minus 220 degrees Fahrenheit in winter. On the other hand, it's possible for a sunlit surface to cross the threshold of 0 degrees Celsius or 32 degrees Fahrenheit, and as much as 20 degrees Celsius or 68 degrees Fahrenheit in summer at the equator in broad daylight. When this happens, the ice doesn't melt, it sublimates. In other words, water changes from a solid to a gaseous state. Water cannot exist in a liquid state on a planet with such a tenuous atmosphere. We have the very example of this on Earth. At the summit of Mount Everest, where atmospheric pressure is lower, water boils at a lower temperature, 60 degrees Celsius or 140 degrees Fahrenheit, instead of 100 degrees Celsius or 212 degrees Fahrenheit. And even then, the atmospheric pressure at the top of Everest is 34 kilopascal. Imagine on a planet like Mars where pressure varies between 0.03 kilopascal and 1.15 kilopascal. But how did these layers of ice form on the Martian mountainsides discovered in 2018? According to the researchers, it wasn't liquid water that trickled down and then froze. Given the conditions on Mars, this hypothesis seems unlikely. What is possible, however, is that they are wind-driven snowdrifts or condensation deposits. These deposits have formed periodically, following the oscillation of Mars' rotational axis, whose inclination varies more slowly, but with greater amplitude than on Earth. All that remains is to take samples from this area to find out more about what has caused these successive layers of barely buried ice. The discovery of ice on Mars also holds promise for future manned missions. Astronauts who one day land on Mars will need to extract water from the Martian subsoil in order to store and drink it. This water could also be used in gaseous form to manufacture oxygen and to supply rockets with fuel, thanks to the methane extracted. December 12, 2022. NASA photographs a strange geological shape on the surface of Mars. A shape that looks strangely like a bear's head. A bear's head on Mars immediately amuses scientists and the general public alike. Look closely. In the photo, you can see a hill with a collapsed V-shaped structure, representing the bear's nose, 2 craters forming the eyes, and a circular pattern, the bear's head. As you can imagine, this circular pattern has nothing to do with a bear. Rather, it's due to the covering of a crater by a deposit of mud or lava. In fact, it's nothing less than a crater, located 251 kilometers or 155 miles above the Terra Serenum region in the southern hemisphere of Mars. It's not a revolutionary discovery, but it's one that's gone viral. This unusual photo, released by the University of Arizona, has gone viral, particularly on Twitter, where it was relayed by the account dedicated to the Mars Reconnaissance Orbiter satellite. It was, in fact, the MRO satellite that captured this image with its high-rise onboard camera. This camera is said to be so powerful that it could photograph a kitchen table from space. This picture of the Martian bear isn't the first to have caused a stir because of its unusual appearance. Regularly, images released by NASA reveal recognizable shapes. A Perseverance shot released in April 2021 had already caused a stir. It showed the silhouette of a man lying on a rock in the middle of the sand on Mars sunbathing. An American UFOologist even tried to prove that it was indeed a man who had been photographed, and that this was 100% proof of intelligent life. The UFOologist went so far as to point out footprints behind the man, leading to the spot where he had been lying down. This phenomenon, which causes our brains to see recognizable shapes, such as faces or animals where none exist, has a name: pareidolia. It's the same phenomenon that occurs when you look up at the sky and see shapes in the clouds. In the case of the man lying on a rock, as in the case of the bear's head, it was indeed pareidolia, proof that sometimes observing things from our human perspective can get in the way of correctly interpreting what we see. February 8, 2023. NASA announces that it has discovered what it calls the best evidence yet of the existence of lakes on Mars. Let's take a step back in time. Today, Mars is a desolate, arid and dried-up world swept by dust storms. A world even more hostile than terrestrial deserts. Temperatures on the red planet rarely exceed 0 degrees Celsius or 32 degrees Fahrenheit, and can even reach minus 140 degrees Celsius or minus 220 degrees Fahrenheit in winter and at night. Atmospheric pressure is very low, averaging 6 hectopascals. Obviously, there is no liquid water on the surface of Mars, but Mars wasn't always such a barren planet. In the 1970s, the Mariner and Viking probes revealed enormous flow channels on the red planet, and veritable canyons that were most likely dug by liquid water billions of years ago. These findings have been confirmed by recent Mars missions. There may even have been large lakes on Mars, as on Earth, which have now dried up. If water flowed on Mars in the distant past, it's because its atmosphere must have been denser than today, and its temperatures higher. Researchers believe that shortly after its formation, 4.5 billion years ago, Mars was very similar to Earth. What they are now trying to discover is why the Martian climate changed so drastically. How did Mars lose its atmosphere? And above all, what has become of the enormous quantities of water that once flowed over the red planet? At present, Mars' thin atmosphere is 95% carbon dioxide and therefore contains only minute quantities of water. Some of this water vapor condenses as ice on the surface of Mars, particularly towards the North Pole, where it forms a permanent ice cap. Thin clouds of ice can also be seen in Mars' atmosphere, again in the northern hemisphere. But all this is just a tiny fraction of the water that once existed on Mars. Considerable quantities must have escaped over time, escaping Mars' gravitational pull. Researchers believe that the remaining water is found in the Martian crust in the form of permafrost. In other words, there is a permanent layer of frost in the Martian crust. But all this doesn't mean that Mars has been inactive and frozen for all these years. There have been resurgences of water, as evidenced by the numerous marks found by probes orbiting Mars. Scientists explain this by the warming episodes induced by the steep inclination of the Martian polar axis. These warming episodes would have allowed the permafrost to partially melt, particularly at high latitudes. During these periods, atmospheric pressure and the greenhouse effect would have increased, temporarily enabling the resurgence of liquid water on the red planet's surface. This scenario is constantly being confirmed by discoveries of traces of liquid water on the arid, rocky surface of Mars. The latest. On February 8, 2023, NASA discovered traces of water waves on the surface of Mars. A major discovery that could provide proof of the existence of a lake on the red planet. This time, it's the Curiosity rover that has discovered these indisputable traces of the presence of liquid water on Mars in the past. Curiosity found rocks whose surface is marked by undulations, potentially linked to waves. Since its arrival on Mars, the rover has been climbing the slopes of Mount Sharp in search of clues to the planet's past. It was at around 800 meters or 2,600 feet above ground level in an area nicknamed the Marker Band that it photographed these undulating rocks, which have been miraculously preserved. An astonishing discovery in a region of Mars that scientists expected to be drier. For the researchers, this is not only the best evidence of a Martian lake ever found to date, but also a major clue to the complexity of the climate on Mars. These stones show that the transformation of Mars from a wet planet to a dry, cold one was highly complex. A discovery that shows us that, like Earth, Mars was also a beautiful planet with a complex climate and weather patterns. The wavy stones have not yet been analyzed. Curiosity was unable to extract any samples due to their hardness. But the researchers are not discouraged. They now hope to find new, softer, corrugated rocks that can be analyzed and reveal their secrets. Perseverance also recently discovered an ancient lake, this time in the Zhurong crater, where it has been since landing on Mars. Between February 28th and March 9th, 2023, NASA's rover took a series of images that make us wonder. What if the red planet is home not to tranquil lakes, but to tumultuous rivers with currents, torrents, and waterfalls? This is what the Perseverance images suggest. Scientists believe that the Zhurong crater, currently being explored by NASA's latest rover, may have been home to a tumultuous river. How did they come to this conclusion? It's thanks to the panorama taken by the rover's Mastcam Z instrument when it was in the former bed of this river. This could be one of the deepest rivers ever discovered on Mars. How do we know it was a tumultuous river? In fact, it's the size of the sediments lining the riverbed that indicates the strength of the current. The larger and heavier the pieces, the more turbulent the river had to be to move them. But that's not all. The Perseverance images show something else. We can see large curved strata, which show that the current was powerful there. However, scientists don't know exactly what the landscape looked like when a powerful river still flowed through the Zhurong crater. Was the rock meandering, i.e. undulating across the landscape? Was it braided, with sandbars in the riverbed and small islands? Thousands of years of erosion prevent us from knowing precisely. But scientists are not giving up hope of one day being able to retrace the Martian landscape of thousands of years ago. Investigations will continue thanks to Perseverance, and researchers are confident of a positive outcome. That's why the Zhurong crater was chosen as the landing site for Perseverance. From Mars' orbit, many clues suggesting that this depression had once been home to a lake. Perseverance quickly proved the existence of ancient deltaic deposits. A delta means liquid water. However, analysis of the magmatic rocks in the crater floor showed only very slight alteration by water. No trace of lacustrine sedimentation had been found either. In other words, it was unlikely that there had ever been a perennial lake in the crater. To explain the absence of lake sediments, researchers had come up with several possible explanations. The sediments had been buried under volcanic rocks, or they had been eroded by the wind. But more detailed observation of the rocks in certain parts of the crater showed that they had indeed been altered by a fluid, but in several stages. The lake hypothesis had therefore been ruled out. This was not a continuous alteration linked to static water. The details of these successive alterations remain unresolved, but the discovery was a promising one. So yes, we found traces of a tumultuous river in the Zhurong crater, but no or very little evidence of H2 gas and iron, the essential energy source for microbial life on Earth. Rest assured, this doesn't mean that there were no organic molecules in the river. Maybe there were, but only sparsely. Or maybe they were using a different energy source as yet unidentified by scientists. August 9th, 2023. Mars research makes great strides forward with another major discovery, published in the famous journal Nature. A major discovery, since possible traces of life have been found on the red planet. The study was carried out by researchers from Toulouse and Lyon with the support of CNES, Canada, and the United States. These scientists have discovered fossil evidence of a cyclical climate on Mars, organized into dry and wet seasons as on Earth. This discovery comes on top of Curiosity's discovery of simple organic molecules. In other words, we have here the ingredients for an environment conducive to the appearance of complex organic compounds and hence life. As you can see, the surface of Mars is not made up like that of Earth. It is not renewed by plate tectonics. It has preserved vast terrains of fossil rivers and lakes, dating back billions of years. Curiosity has been exploring these remains since 2012. During its long mission on the red planet, the rover has been able to detect the presence of simple organic molecules that may have been formed by geological or biological processes. But for primitive life forms to emerge, favorable environmental conditions are required. Conditions must be right for simple organic molecules to organize themselves into complex organic compounds. This was the missing piece of the puzzle until the discovery announced on August 9, 2023. Thanks to curiosity, the research team discovered hexagonal salt deposits in sedimentary layers dating from 3.8 to 3.6 billion years ago. These patterns bear an uncanny resemblance to those found on Earth, in basins dried out during the hottest seasons. Could they be fossil evidence of a cyclical Martian climate like that on Earth? Researchers are convinced the climate on Mars could in the past have been organized into dry and wet seasons. But it's precisely this type of climate that allows molecules to interact, a regular cyclical climate. In this way, molecules can form complex compounds such as RNA, which are the precursors and building blocks of life. In other words, these are the first necessary steps in the synthesis of biological molecules and thus of life. These conclusions have been verified in the laboratory. On Earth, there are no remnants of the natural processes at the origin of life. This discovery gives hope to researchers. Another planet may finally be the key to unlocking the mystery of life. A few months after this major discovery, it's the turn of the InSight mission to reveal more of the red planet's secrets. On October 26, 2023, another study was published in the journal Nature, once again challenging our knowledge of Mars. In September 2021, the InSight probe recorded a meteorite impact on Mars. The seismic data from this impact were then analyzed by the InSight mission team. The results of these analyses were published on October 26, 2023. The results of their study are like a paving stone in the pond. They propose nothing less than a new model for the interior of Mars. According to the proposed new model, the structure of Mars is made up of a core, followed by an inhomogeneous mantle composed of a layer of molten silicates. This model could explain all the geophysical observations made by the various Mars missions, but it could also provide a coherent explanation for the evolution of the red planet since its formation. How did scientists come up with this new model? In fact, they studied the propagation of waves generated by the September 2021 meteorite impact. And according to their findings, at the base of the Martian mantle is a layer of fused silicates. Starting from the outside, we would then have the following successive layers: the solid mantle, a thinner layer of partially melted silicates, the famous thicker layer of fused silicates, and finally, the red planet's metallic core. The new model also calls into question estimates of the size and density of the Martian core. According to the new data, the core would be 150 to 170 kilometers, or 100 miles smaller and 5 to 8% denser than previously estimated. It would contain fewer light elements than previously thought. Above all, such an internal structure means that the Martian core is isolated. As a result, it can no longer cool and generate a magnetic field like the one that existed on Mars during the first 500 to 800 million years of its evolution. What we have learned from this discovery is that Mars and Earth may have been similar at birth, but their internal evolution has been completely different. Researchers can't wait to find out more, and neither can we. At the end of 2023, a new discovery once again changed our idea of the planet Mars. Long considered a dead or inactive planet, Mars has nonetheless experienced recent volcanic activity. At least that's what a study published in December 2023 has revealed. Mars, like Earth, is known to have experienced intense volcanism. In fact, the largest volcano in the solar system is Olympus Mons, one of Mars' volcanoes. Olympus Mons is over 22 kilometers or 14 miles high. No structure on Earth can compare with such a geological monster, not even Everest, at 8.8 kilometers or 5.5 miles high. Above all, it's an indication that Mars is capable, or has been capable, of producing quantities of lava that Earth has never been able to produce, and over very long periods of time. Let's return to the discovery that was revealed in December 2023. It wasn't made in the Olympus Mons region, but in another equally impressive volcanic region of Mars, Elysium Planitia. This is the second largest volcanic region on Mars. Imagine a plain, 3,000 kilometers or 1,900 miles in diameter, made up of piles of lava flows. In this quiet, desolate landscape, 4 major volcanoes rise up. Impressive in their size, these volcanoes are clearly extinct. That's why Mars has long been considered a dead planet. And yet, the discovery we're talking about has cast doubt. Mars may well have experienced major eruptions fairly recently. In 2022, a study revealed the presence of a giant mantle plume beneath the Elysium Planitia region, a sign of intense volcanic activity in the recent past. At the end of 2023, a new study confirmed these results and even specified the age of the last volcanic events in this Martian region. And the figure is staggering. Mars is thought to have experienced over 40 volcanic episodes in the last 120 million years. To give you an idea, this corresponds roughly to the time when dinosaurs reigned supreme on Earth. Each of these 40 volcanic eruptions produced huge volumes of lava that only Mars can produce. We're talking truly impressive volumes, up to 16,000 cubic kilometers of lava, or almost 4,000 cubic miles. This lava flowed through large fissures. The last of these 40 volcanic episodes would be no older than 1 million years, which on the scale of the chronology of the universe is very recent. At this stage, scientists are not ruling out the possibility of a volcanic awakening on Mars in the future. If Mars volcanoes were to erupt, what would that mean for us? Volcanic eruptions are capable of bringing large quantities of water to the surface. The magma itself contains a lot of water, which could be vaporized in the atmosphere and fall back to the planet's surface in the form of ice particles. And if there is ice trapped underground on Mars, as is probably the case, the arrival of magma in the Martian crust could melt it and create large sudden floods on the red planet's surface. Remember, Finding water on Mars is crucial for two reasons: to find traces of life on the red planet, and to prepare for future manned missions to Mars. We have now reached the end of our journey through the most extraordinary discoveries on Mars. In recent years, our knowledge of the red planet has been challenged time and again. With the discoveries of Curiosity and Perseverance, but also those of probes orbiting Mars, such as InSight, we have been able to answer many of the questions we had about our neighbor in the solar system. We now know beyond any doubt that liquid water did indeed exist on Mars several billion years ago. But we also know that in the meantime, the Martian climate has changed drastically and the planet has lost its atmosphere. The water on the planet's surface, the water in its lakes and rivers, then evaporated, turning Mars into an arid desert planet. Today, water can be found on Mars, but only in the form of small droplets condensing in the morning at high latitudes, or as ice in the polar ice caps. Scientists are constantly striving to meet these challenges with a host of innovations. The latest of these is the creation of islands in which humans can live. Harvard researchers have suggested using shields made from silica aerogels. Silica aerogels are very low-density solid materials reputed to be among the most effective thermal insulators. Shields of silica aerogels measuring just 2 to 3 centimeters or 1 inch would be effective in protecting us from UV radiation and raising temperatures on the red planet. But until all these ideas are put into practice, one question remains to be resolved: life on Mars.